There we go. All right, how's everybody doing? Thanks for signing up for the tutorial and thanks for coming. My name is David Anastasiou. I'm an associate professor in the Computer Science and Engineering department. I'm also the director, the School of Engineering director for the HPC Center, and I'm happy to have you all here. I assume you're all interested in using Wave HPC for something. So today we're gonna do. Unfortunately, we will not have time for all of this, but we'll do the first part of this introduction to HPC using Wave. So we're going to learn about what the HPC is all about. We're going to learn about how to access the HPC, who can access the HPC, how do you get an account and things like that. And we'll talk about data management. How do you transfer files in and out of the HPC and things like that. Likely we will not get to talking about software environment and the job execution. That's going to be a follow-up tutorial in a few weeks. However, I have a secret that I'll tell you at the end about how you can learn about that even before we meet again. And throughout this whole entire thing, there will be examples. I will show you as we go how to do things. All right. So first, what is an HPC? Oh, and by the way, feel free to stop me at any time if you have questions. Raise your hand or just shout or whatever. I'm here to answer your question. All right. So first of all, what is an HPC? HPC stands for High Performance Computing. It's nothing more than a team of computers. However, unlike your laptop, these are very powerful computers that we have in a data center. They're very powerful servers that have many, many, many compute cores, tons of RAM, and often accelerators like GPUs that help us do computation a lot more efficiently and effectively than your laptop can do. So in addition to the compute nodes, these very powerful servers, the HPC also has a very high-speed interconnect. What that means is it's a network that allows these servers to communicate very, very fast. It's a specialized type of network. It's low. It's not only ultra fast speed. But up to 200 gigabits per second, but also the access between the nodes is done extremely fast, much faster than a normal network would do. So in addition to that, we have a shared file system. So that means any file you can access on, say, the login node of the HPC, you can also access on any of the compute nodes. All the nodes will have access to all the files as a shared parallel file system. And finally, this huge resource needs to be shared by many, many people at the university. So we do that via a program called Slurm. So this is the scheduler. This allows us to basically allocate resources as needed. So you'll see later, in order to access a particular resource on the HPC, you have to ask for it. And once that resource is available, then it's given to you and then you can use it in different ways. And I'll show you different ways to do that. So one of the major benefits of the HPC is the power of parallelism, right? It has servers with many, many cores in its CPUs, as well as GPUs, which have thousands of cores each. So this allows your simulations, your AI training, your AI inference, whatever you're doing, run much, much faster than it would on a normal laptop. So the benefits summarized here, you get huge speed increase, especially if you're using parallelism in running your experiments and doing your research. You get lots of storage. So we have terabytes and terabytes of data. storage capabilities on the HPC. You get a portion of that, and all of it is completely free to you. So the university bears the cost of running this HPC system, electricity, the network, everything. So everything's completely free to you. Okay, so now I'm going to give you a little tour of the HPC itself. So the HPC is what we call a heterogeneous system. That means it has many different types of servers in it, many different types of nodes. So first we have the compute nodes. Or the CPU nodes. So this is the CPU partition, as you'll see later, I'll show you in a little bit, in the HPC. So this is 4 Dell servers, each with 96 Intel Xeon Platinum CPU cores, so 96 cores, and 512 gigs of RAM. And then we have 2 high memory nodes, which are very similar, but they have 2 terabytes of RAM each. And then we have, so that's the MEM partition. And there's also the CMP partition that actually combines these two together, CPU and MEM together, because they basically use the same Platinum, Xeon Platinum CPU. So you could basically do computation on any of those servers. And as long as you need up to 512 gigs of RAM for your computation, all of those servers would act exactly the same. And then we have the hub nodes. The hub nodes are actually much less power. They're more like desktops than powerful servers. They're L8 Dell workstations. They're primarily used for our Open On Demand service for interactive tasks, and I'll show you that later. Now, where the major part of the HPC comes from is actually our GPU nodes. And we have 2 types of general purpose GPUs available for everyone to use. In addition to the hub nodes themselves have an RTX GPU each with, I think, 12 gigs of RAM or something like that. So, fairly limited, but still useful for a lot of tasks. But then we have the GPU partition, which has 4 Dell servers, each equipped with 2 NVIDIA V100 GPUs, each with 32 gigs of VRAM and 384 gigs of RAM, and Intel Xeon Gold CPUs with 80 cores. So actually 2 CPUs, 40 cores each. And so that's 8 V100 GPUs, which are very powerful and you can use for AI training and inference and so on and so forth. In addition, we have 8 AMD GPUs in one very powerful server with all 8 together in one server. So these are the AMD Instinct MI100 GPUs. All of those also have 32 gigs of VRAM. And that server has 256 cores of AMD EPYC. So the NVIDIA GPUs are part of the GPU partition, and the AMD GPUs are part of the AMD partition. All right. In addition to all of these servers, which are general purpose, available to anyone to use, and you do not get, whatever resources you ask for, when you get them, they're yours to keep until your job is done, right? Or until you run out of time. We'll talk about that later. But in addition to that, we also have a whole bunch of additional servers, additional nodes that are called condominium nodes. So these are nodes that belong to some research lab. Like my research lab has 4 condominium nodes. Professor Ignat's lab has a condominium node, and so on and so forth. The different professors have purchased these nodes using research funding, and they belong to their lab, right? However, they're still available to use by everyone whenever those nodes are not being used by the lab, right? The main trick here is that if you submit a job to one of those nodes, and then the condo owner, right, or somebody in their lab submits a job that needs those resources you're currently using, your job will be preempted. It will be killed and restarted on a different condo node, right? However, having said that, then these are still really good resources for you to use when those condo node users aren't actually using them. Go ahead.
Does it like let you know when that happens?
Yes.
Or does it,
Yes. So you, assuming you schedule it correctly, you can set your email basically and say, oh, I want to be notified whenever something happens to my job, like when it starts, when it ends, and then you'll get an email. Oh, your job was killed and restarted. Your job has now restarted on some other node, right? The other tricky part about the condo queue is it's completely heterogeneous. So different types of nodes altogether. So you have to be a little more careful. And again, we'll cover this probably in our next session, but you have to be a little more careful of how you schedule your job because, if you need a particular type of GPU, you might not get it if you just say, oh, schedule on the condo queue. So there's nodes with L40S GPUs, A16 GPUs. Soon there will be a few T4 GPUs. I have a node with A100 GPUs and things like that. Not right now, but in about a year or so, we're going to have some GH200 GPUs in there. And those nodes are completely different because the CPU isn't an i386 CPU, it's actually an ARM CPU. So the software stack for those nodes is completely different. So again, a little extra care is needed here, but lots of extra resources for you to use. So it turns out the condo nodes themselves have more than twice the power of all the other nodes combined. And we're only adding to those condo nodes. So there will be more condo nodes being added in the future as more faculty, get research funding that can purchase condo nodes. Okay, so in addition to these very, very powerful servers, we have high-speed storage. We have a 92 terabyte Fujitsu All SSD storage and a 456 terabyte Dell EMC array storage, which we use for our parallel file system. We also have a new Vidura parallel file system with about 350, maybe 400 terabytes of usable storage, but that's not yet in production. And we're hoping to add another parallel file system in the next year sometime as well. So all of this storage, again, needs to be shared by everybody at the university. But you will get, when you get an account, you get some of that available to you for your research needs. And then we talked about the high-speed interconnect. So we have a Mellanox InfiniBand network. In addition to that, there's an Ethernet 25 gig network, gigabits per second network that acts as a backup, and then some of the nodes don't have Mellanox, so they act as primary for those nodes. Okay, so finally we have the software environment, right? So the HPC is servers, the networking hardware, and then we have the software environment. The HPC itself runs on Linux. Rocky Linux to be exact, Rocky Linux 9. So, if you're not familiar with Linux, you should learn. It's very useful. And then we have the job scheduler. So this is Slurm. Without it, you can't run this interactive resource or this resource with many, many users. And then we have software management. We have modular software management. So, and then we also allow Conda environments to be created. And there's even, I forget what it's called. It's not Singularity anymore. Some virtual environments you can create within the HPC as well. All right. So this is the most important part of this whole entire tutorial. The way the HPC works, again, because it needs to be shared by everybody, is you get access to the HPC via the login node, right? But when you get into the HPC, you need to request your resources. So you can prepare a batch script or use some other interface to request what resources exactly you need for your particular job, right? So that may be, oh, I need 20 cores with 48 gigs of RAM, and I need it for 5 hours, right? So you specify that, and then those resources are allocated to you from the pool, right? If there's none available, then your job waits in queue until those resources become available. It's a priority queue. So, eventually your job will come up to the top of the queue, and then you'll be given those resources. And then if it's a batch script, your script will just run, and then you'll get the results. You'll get an email when it's done, or if it ran out of time, or if there's an error or something, and then you can go back and see what happened and go again. So yeah, once you submit the batch script, then to Slurm, then the Slurm will figure out what resources are available, and then once those resources are available, it's going to start executing, and then it's going to write the results to the shared file system, and they'll be ready for you to analyze. Okay, so speaking of, let's move on to, so that was a short intro to what HPC is and what are the resources available in our specific HPC. So now let's talk about the system access. Okay, so first things first, you need to log in, right? So, but before you can log in, you need to get an account. And you need to, might need to install some software on your PC to be able to access the HPC. And then, of course, because the system is a Linux system, you might need to brush up on your Linux commands, right? So how do you request an account? So first things first, who can access the HPC? Pretty much, so the HPC has two mandates. One is to support teaching, and two to support research at the university, right? So for teaching, a professor wanting to use the HPC will request access for their class to use the HPC, and then everybody in the class will get an account created, and they can access the HPC. So all of my classes, for example, always use the HPC. So I'm teaching 140 this quarter, so I sent a request last week, and they created a group for my class and created accounts for all my students. And now everybody in my class can log in and use it for the entire quarter. The alternative is if you do research, you can use the HPC, but you have to have an advisor for that research. So a professor is advising you in your research, and then they will basically be responsible for your activities on the HPC, and they need to vouch for you to have an account created. Okay, so those are the two alternatives. How do you access? You need to submit a ticket. So there's a link here. There's a link on the HPC website. Click there. In order to access the ticketing system, you have to go through Duo authentication, log in, and then just request. So use the user account creation bullet in the form, and then fill out the necessary information. If you're a professor, you need to submit the output from Workday for the SU course roster of your class. And that is the information needed by the systems administrators to be able to add the students to the group. If you're just asking for you or for you and a couple students, you can just type in that information there. they'll need, name, SU username, ID number, and things like that. And if you're creating, say, a research group or a group for a particular purpose, what should be the group name and things like that. All right. Any questions so far? I know I'm kind of flying through pretty quick because we only have an hour. So, all right. Okay, so once you've requested an account, then you can, once an account is created, then you can start using the HPC. How do you do it? So the primary way to, that you get the most effectiveness out of the HPC is via command line. So if you want to connect via command line to the HPC, we use an application called SSH. But if you have a Linux laptop like I do, or you have a Mac laptop, then the command line or terminal is built in. All you have to do is go to the terminal and use the SSH command. It's all built in, ready to go. If you are a Windows user, then you have to actually download and install an application. So for example, Mobile Xterm or PuTTY are applications that you can use to connect, or Windows Subsystem for Linux. That's another way to do it. Or there's some other, Linux-like terminal applications for Windows that you can try. Okay. So again, the golden rule of the HPC, and again, this is the other most important slide of the entire deck, is when you log into the HPC, you're going to log in through the login node. You cannot use the login node for any computation, right? The login node is shared by everybody. There may be, 50, 100 people all logging in at the same time through the login node. If you start doing some heavy duty computation, you're going to bring down the entire login node, and then everybody loses access, right? So you do that, you get banned. So don't do that, right? No computation on the login node. You can, request resources, use Slurm. You can do some light stuff like file transfers or writing code or even compiling code, as long as the compiling doesn't take an hour, right? But don't do heavy duty computation on the login node. That is a no-go. Okay, where do you find help? So the website is the best place to find help. su.edu/wave/wave-hpc. And you can also send an email to wavesupport@su.edu. But I think they prefer if you submit a ticket, which again, the link is on the website. So that's a better choice. But you can also email if you can't find the ticket or whatever. Okay, so now, very important, you cannot access the HPC from home. Okay, the HPC is a secure resource, and as such, can only be accessed from the SU network. What does that mean? If you're on campus, use one of these lab machines, you can access directly, SSH into it. If you're on your laptop and connected to Eduroam, you can access via SSH directly, right? But if you're at home, you have to first connect to our network here via VPN to be able to access the HPC. Yeah, so, very important. Security is everyone's concern, not just mine, not just his, right? It's everyone's concern. Everybody has to, vouch for everybody else at the university. So you have to be careful with your own account. Don't give your password to anyone, things like that. But also, we need to keep the HPC secure for everyone. Okay, so as I mentioned, there's two ways to access either on-campus network, either LAN or Eduroam, or if you're off campus, then you have to connect to VPN first and then access. Okay, now once you do connect to our network, there's a couple different ways to access the HPC. One is terminal, like I mentioned. The other one is what we call open on demand. So this is a web-based interface for Jupyter Notebooks and also remote OS access and things like that. So I'll take a quick break here and I'll show you. This. All right. So here I've got a terminal, so I can type in SSH and then my username. And then login.wave.su.edu, right? And when I type this in, if you've never logged in before, it's going to ask you to accept the connection. You only do that once. Once you've done that, then I'll ask you for your password, and then it's going to log you into the HPC. I've done some magic stuff, which I'll tell you about later. So when I do this, it's just going to log me in directly. And oh no, yeah, it's going to be a little slow here. So there is an issue where, yeah, if you just do this directly, it's going to be delayed a little bit, 10 seconds or so. There's a special flag you have to put in that makes that delay go away. That's only if you're connecting from a Linux system, which I am. So I've done a special thing, and I can just type in SSH HPC and then connect directly without ever typing in a password. And then you notice there wasn't that delay. So what I've done is I've used a configuration file to specify those parameters, like my username, where I'm connecting to, and things like that. So I'll show you that in a little bit. But anyway, now that I'm connected to the HPC, now I can see stuff about the HPC. So for example, these are the different queues and their status. So there's a mixed usage of CPU 04, GPU 01 and 2. CPU 02 is currently down for some reason. GPU 03 and 04 are idle, so 4 GPUs readily available to be used. A bunch of hub nodes are idle, and a bunch of condo nodes are mixed usage, and a bunch of them are idle, and that's that. Okay. So now that I have access to the HPC, I can use commands like I used sinfo or sbatch to submit a job, or srun to submit an interactive job, or things like that. I will cover those later, right? So this is one way to access the HPC. The other way is, here we go, is via Open on Demand. So Open on Demand is this web interface to the HPC. This is the link to it. When you log in, it asks you for your SCU username and password. Again, you won't be able to log in until you have an active account on the HPC, but once you do, you get this interface here. And then from here, you can do things like transfer files through this GUI interface. You can look at active jobs on the HPC or create a new job to submit. You can get a terminal, a web-based terminal. So here's same thing, but in a web interface. And you can, and what most users use it for are these interactive apps. So here we have Jupyter Lab, which gives you basically Jupyter notebooks to do interactive coding in. MATLAB for using the MATLAB application interactively, and Compute GUI. So this gives you basically a Linux desktop interface, complete with graphical user interface, and then you can do whatever you need to do in that system. Now, very important, these when you use any of these resources, I'll go to Jupyter Lab here. It will ask you what you need. right? So, for example, there's a resource profile here, so you can choose, oh, I need 2 CPUs, 8 gigs of RAM, 1 GPU for 3 hours, and shared access. Or I need, one of these AMD GPUs for 3 hours, with 2 cores and 32 gigs of RAM. Or I need 8 cores with 256 gigs of RAM in the CMP partition, right? Notice there's a limited set here, and also the time is limited. So this interactive usage is limited to 3 hours at a time. Then you can also choose the Python version, so 3.9, 3.12, or 3.13 in this case, and then you can launch it. And that will give you a Jupyter notebook that you can then play around in. Now, same thing with MATLAB. So if you go to MATLAB, then it's going to ask you what MATLAB version and how many resources you need. Same thing with Compute GUI, right? So there's different. So this interactive usage is more limited. Now here on this side, you can see these queues have much larger time limits. So if you're using the environment interactively or in batch mode through the terminal, you have much more lengthy time to use it. So for example, the CPU queue gets you up to 4 days and 4 hours. The GPU queue gets you up to 2 days. The hub queue gets you up to 1 day, right? And if you had your own condo queue, like I do, that gives you up to 7 days, right? So you can have some really long training sessions if needed for a particular algorithm. Okay. Any questions so far?
What
Yes.
does the shared access means in the Jupyter?
Yeah, so that means that you will not be the only you may not be the only one accessing that system and that GPU, right? So other people might be accessing that same system and running stuff on the same GPU at the same time. If you use this one, which is not shared access, then the entire node is reserved to you. So there will not be anybody else using that GPU at the same time. Yes.
And for the device based with Linux operating system, does it have any requirement of the device? Like if I access to the web user interface through Raspberry Pi, is it possible?
Can you access the HPC via Raspberry Pi?
Yeah.
Via an SSH session from Raspberry Pi, or what? Or through the web from Raspberry Pi?
SSH.
Yeah, you can SSH from any interface, any operating system that allows you to SSH. Yeah, that has the SSH program, right? So yeah, you can SSH from a Raspberry Pi. You can also use Open on Demand from a Raspberry Pi because I assume Raspberry Pi has Linux on it, right? So yeah. So yeah, your laptop or a Raspberry Pi or your tablet. I've actually connected from my phone. I have applications on my phone that allow me to connect a terminal into the HPC and run jobs and write code and whatever. So I've done that while traveling. So yeah. All right. Any other questions? Okay. All right, let's go back to the slides. Okay, so method 1 via SSH. So again, you type in SSH, then your username at login.wave.su.edu, and then you're going to be asked to whether you want to connect, and then you'll be asked for your password, and then it'll connect. So this is best for managing files and directories, editing scripts with terminal-based editors, compiling code, submitting and monitoring jobs with Slurm, and so on and so forth. And then method 2 is open on demand. So this is best for interactive data exploration and prototyping, developing code in notebooks, creating visualizations, teaching and workshop environments, and things like that. There's a third way that coders like to use, and that is via VS Code. So from VS Code, you can actually directly SSH into the HPC, create a remote VS Code session on the HPC, and then you can code directly on the HPC from your laptop's VS Code environment. I'm not covering that here. There are tutorials on how to do that on our website. But that's a third way. It's really method 1 because VS Code is using SSH underneath to connect and sync files between your laptop and that environment. Okay, all right, so we already covered this. Okay, so here's that secret sauce that I was telling you about earlier. So if you don't want to have to type your username at login.wave.scu.edu every single time, I highly suggest you set this up. So basically, if you're in a Windows, if you're in a Linux environment or a Mac OS environment, in your home directory, that's what that tilde means, /, that means home directory. You need to create, if it doesn't already exist, a .ssh directory, and within that .ssh directory, you create a file that's just named config, no extension, nothing, just config, right? And then within that file, you can put in host, and then after host, give it whatever name you want. In this case, I gave it 2 names. I gave it Wave and HPC, right? And then the next 3 lines are configuration options for that connection. You need to put in a tab or 4 spaces to start with, and then whatever the configuration option, so host name, and then login.wave.scu.edu, user, and then your username. And that's the third configuration that I was telling you that fixes that 10-second delay logging in from Linux machines. GSS API authentication equals no, right? So you put those things in your config file, and then you no longer have to type in all of that. Like you saw me, you just type in SSH HPC or SSH Wave, and then it will log in directly to the HPC, right? That's part 1, okay? Part 2 is a secret, secure handshake. So that's SSH keys. So some of you may be familiar with SSH keys, or you may not. The way it works is you create a very secure private key, which lives only on your laptop and is not readable by anybody except your own username. And then you create a public key, which is paired to that private key, and you share that public key with any system that you want to log into. So in this case, the HPC, right? And once you do that, then the SSH application can use this public-private key combination to let you in without asking for your password. So that's how I did it, where it didn't ask me for the password, right? So how do you do it? It's very simple, right? If you've never done it before, you have to run this command, ssh-keygen. Again, this assumes you have Mac OS or Linux. If you have Windows, you have to do some research. Just figure out key-based authentication for Windows. Once you do this, then go through the details, and it will create that private key and the public key. And then you run one more command, which is ssh-copy-id, and then you're supposed to tell it where it should copy it to. So if you didn't have that config file, you'd have to say username at login.wave.scu.edu. But since we created that config file, I can just say ssh-copy-id wave, and then it will ask me, are you sure you want to copy your public key to this system? You say yes, and then it will copy it. once it that first time, it will ask you for your password, right? But then anytime after that, you no longer need to put in your password. It will go in directly. Now, very important. This is not just for SSHing into the system. This is also for doing anything that requires SSH under the hood with a system. So for example, VS Code. If you want VS Code to be able to connect to the HPC directly and start a remote session, you need to do this so that it doesn't ask you for your password every time, right? If you want to copy files back and forth using SCP or rsync, which we're going to cover in a little while, again, if you've done this, then you just tell it to copy a file, it will copy it. Otherwise, it will ask you again and again and again for the password. Okay. So yeah, now I can just type in SSH Wave or SSH HPC, and it will just go in directly. All right, so the last thing, we only have about 15 minutes left. So the last thing I'm going to cover for today is data management. And then hopefully there's going to be a few minutes for additional questions. Okay, so data is the foundation. We now know, well, actually, no, we haven't covered that yet. But anyway, ignore that part. So the goal here is to understand the layout of the land on the Wave HPC system. Basically, what file systems are available to you. And the key concept here is where you store your data dramatically impacts performance, and also, whether whether your data is backed up, for example, right? Whether you get to keep your data if you happen to lose it. So you have, by default, when your account is created, you get access to 3 different file systems. One is your home directory, right? So that's $home, capital home. That directory is limited to about 50 gigs, and that's where your configuration files go and different things like that. Then you have Wave projects. You will get a group directory there for your entire group. So for example, for my CSIN 140 class, there's a group there called CSIN-140-SP26. And that group folder is available to everybody in the class, and everybody can put files there. And then similarly, there's a /wave/scratch/ same group name, and that you can also put files there. So let's go through each of them individually. So the home directory has a fairly limited quota, which is 50 gigabytes, but it is backed up regularly, right? So the purpose here is use this for your personal configuration files like bashrc, SSH keys, and also small code repositories. The golden rule here is do not store data sets or Conda environments. You can store some Conda environments, but Conda environments tend to blow up quick, right? So I've run into the issue where my entire home directory system was filled in because of Conda environments and things like that. What happens then is your stuff won't run. And sometimes you can't even log into the system because your home directory is too full, right? Or it lets you in, it lets you log in, but some of the stuff doesn't work until you clear some space from your home directory. It's a good idea to keep the home directory fairly clean, and do not store large things like Conda environments there. Then you have the projects directory. So again, that's /wave/project/ your project name. So typically you get something like 200 gigabytes for a project. And yes, this is also backed up regularly, daily. So this is where you should store your Conda environments, data for your project, your results, and things like that. Excuse me. Okay. And then finally, we have Wave Scratch. So Wave Scratch, your project name, if it doesn't exist, you can ask for it, and they'll create it for you. Very important, this one is not backed up, right? Scratch is not backed up. So use this only if you really need more data or more space than you have in your projects directory. For example, you're doing some data processing for your project, and the initial data is like, I don't know, 3 terabytes, right? But you only have 200 gigabytes in your projects directory. That's not going to work, right? So you can put it in Scratch and do your data processing, get it down to what it needs to be, and then move it over to your projects directory and then do the rest of the stuff, right? So the Scratch space does not have a limit, right? So you can use as much of it as you need. However, what it does have is an automatic cleaning policy where any file that's older than 30 days will be cleaned out daily, right? So this is a little tricky because, say you download a data set that's 3 terabytes, right? And then you unzip it, it comes in a zip file or something, or tar.gz or something. And then you unzip it, and it contains a bunch of files, and all of those files are older than 30 days. If you just leave it there expecting to see it there the next day, you're going to find it's all gone because it's been deleted, right? So one trick here is you can use the touch application to basically update the timestamp on all those files. You can write like a bash script to go through all the files in an entire directory and just touch them all. And then it's saved for 30 days. So keep that in mind. There's another file system called datasets. So this is Wave datasets. So this is 4 datasets that are going to be, reused many times for potentially, many people in your lab or something like that. So this can be optionally created. You have to ask for it. Quota varies. So this is for large data sets used by more than one member of your group for more than one project. Okay, so next, how do you transfer data? So the primary data transfer commands you should think about using are SCP and rsync. These are basically applications that allow transferring files securely. They use SSH under the hood to basically connect to the HPC via secure connection and then transfer all the data bytes to the location. And they allow transferring both ways. Now, how do you do it? You need to run these commands from your laptop. Do not run these commands from the HPC. So if I SSH into the HPC, I can't then say secure copy this file. Even though the file is actually on the HPC, I can't say secure copy this file to my laptop, right? Why? Because the HPC doesn't know your laptop, doesn't have a way to access your laptop, right? When you say SSH HPC, it's actually SSH, your username at login.wave.su.edu. That domain name is actually associated with an IP address that is a publicly available IP address. So basically anybody in the world, or at least anybody that's connected to our VPN, can get to the HPC via that public IP address, right? But your laptop is sitting behind some network and gets a dynamically assigned IP address. The HPC knows nothing about where your laptop is in the world, so it cannot send files to it, right? So both of these commands you have to run from your local computer, right? So how do you do that? So basically, if you want to upload a file to the HPC, you go in the terminal on your laptop to where the file is, and then you can say secure copy, SCP, your file name, and then the location. Again, if you've done that config file, then I can just say HPC : and then the path of where that file should go, right? If it's if I didn't do that, then I'd have to type in that whole thing. Username at login.wave.scu.edu, then : then the path where the file should go, okay? Now, if I download a file, then all I have to do is just replace or swap the parameters, right? So I still do from my laptop, I go to the directory where I want to copy the file, for example, and I type in SCP HPC : the file path, the full path, and then dot here means copy in the current directory. Or I can give it a full path of a directory on my laptop where the file should go, right? And if I use the -R, that means recursive, then it will copy an entire directory, not just a single file. Okay, rsync works in a similar way. It does synchronization, right? So it's a little smarter. It can synchronize an entire directory. It can actually compress and uncompress. So it can do things much faster. And also, if I've already sent the files over and I make maybe a change to 1 or 2 files, and I tell it to sync again, it's only going to send those files that have changed, right? So you can read the manual for rsync to find out more information. And then there's some graphical data transfer clients as well, like WinSCP, CyberDuck, FileZilla, and other things like that. And again, for those configurations, if you have done that config file, you can just give them that HPC name, or otherwise give them the full information of how to connect. Okay, so that's all for today. Unfortunately, we only have an hour, so we still have some minutes. If you have any questions, the plan is to have the second portion of this where we will talk about setting up your software environment on the HPC, so how to use modules as well as Conda environments and things like that, as well as actually executing jobs through Slurm. Unfortunately, I'm traveling for the next 2 weeks. When I come back, there's another tutorial I'm giving on doing AI workloads on the HPC. But then probably the week after that, or in a couple weeks after that, then I'll do the second part of this tutorial.
Slides.
Oh, I'll post them on the HPC website soon.
The slides recording website.
Yes, as well as the recording. I think we're recording, so I'll post the recording as well. Okay. Any other questions? All right. Well, thanks for coming.
Thank you.
Yep.
Helpful for me. I'm a
Good.
beginner.
Good.
You're really good.
Excellent. Excellent.
Thanks a lot.
Yeah. Oh, I should say,
Because the first lab is
I did tell you all at
Actually,
the
we just set
beginning,
it up.
I have a special surprise for you, and I forgot to mention it. So the special surprise is, all of this info is also part of this course that I have on Coursera, on Camino, called AI ML on the HPC, which you can access by going to the HPC website. Under tutorials, there's video tutorials or something, and then there's a link to the course there. If you go to that, it's a timed course that has all this info and the stuff I'm going to cover next time, and more stuff about AI ML stuff. And it's all pre-recorded videos. You can go at your own pace. So feel free to go through that instead of just waiting for 4 weeks until we continue this. But of course, feel free to come back to that session too. All right?